Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Bismillahirrahmanirrahim. Dear students, today I will discuss taper and taper turning. And the most important thing is that I will derive a formula for finding out the tapered angle. So at the end of this lecture, you will be able to understand how this formula comes from. So let's start. So first I will discuss what is tapered. So a tapered may be defined as uniform increase or decrease in diameter of workpiece measured along its length. So it is uniform increase or decrease in diameter measured along its length. The shortest definition measured along its length. So I will repeat the definition again is that a tapered may be defined as uniform increase or decrease in diameter of workpiece measured along its length. And this is what we call tapered. So in lathe machine, taper turning is operation that is used to produce a conical surface by gradual reduction in diameter of cylindrical workpiece. So basically if I draw it, so it will be a uniform increase, or you can say increase or decrease in the diameter, but in lathe machine it is used to produce conical surface as well. So this tapered part has wide application in the construction of machine, because you know that almost all machine spindles have tapered hole which receive taper tank of various tools and work holding devices. So now we will move toward derivation of the formula, that is tangent of alpha is equal to d minus d divided by 2l, and during this you will be able to learn what is alpha, what is capital D, what is small d, and what is small l. So let's start. Let me choose another marker. For example, let this is your workpiece, conical workpiece. For example, let this is your conical workpiece or conical part. Clear? And you can see that this is the let from this to this is the larger diameter. Clear? So I will represent D as capital D as larger diameter, and let this is your smaller diameter. Clear? And let this is the axis of the workpiece. Okay. So now you can see this is D, capital D is equal to larger diameter, larger dia, small d is equal to smaller dia, and let from total length of the workpiece from this to this is represented as small l, and this is equal to length of tapered, or you can say taper, it is taper length. Now let if you extend this Clear? These edges to the center, so it will meet the center point axis at certain point. So let this total angle is known as full tapered angle. Full tapered angle, and this full tapered angle is equal to 2 alpha. So definitely this will be equal to half tapered angle, and that will be equal to alpha. So that will be alpha. Clear? Now let this point is C point, and this point is another E point. This point is let A point, and this point is let's say another D point. Sorry, let's say this is F point. Here, so we have A, C, E, and F. So if you draw a line from point C to which intersect this AF perpendicular, and this line must be parallel to this axis. So let this point is B point. Clear? Now you can see this axis is making an angle of alpha with this edge. So definitely this will also make an angle of alpha. So this angle is also alpha. Clear? So we will interested to find out this angle alpha. So 2a is equal to alpha is equal to full tapered angle, and alpha is equal to half tapered angle. Now if you look at this triangle, right angle triangle ABC, so if you take the tangent of alpha, so tangent of alpha will be equal to AB over AC. Clear? So it will be AB, and you know that AB over BC, not AC. AB over BC. So if you look BC is exactly the length, tapered length. So instead of BC, I will write small l. Now you can see that, let me show you. You can see that this AF is equal to capital D, which is, and this EC is equal to small d. We are interested to find out AB. Clear? So AB will be equal to what? As you know that AF is equal to EB plus AB. Clear? You can see EB plus AB. And again, if I draw a line from here, clear, to this point. So let's say this point is G. Clear? So I can also write AF as AF is equal to FG plus GB plus AB. So you can see this is AB plus BG plus FG. Clear? So now FG is equal to, this is unknown, so FG, and as FG and AB is same, so you can write AB as FG. Clear? Now this is equal to AF. Clear? So AF is equal to 2 times of FG plus GB. Now we are interested to find out FG. Clear? So we are interested in this distance. FG or AB. Clear? So 2FG will be equal to AF minus GB. Now AF is the largest diameter. You can see AF is the largest diameter. Minus GB. GB is smallest diameter, which is equal to EC. I can also write GB as smallest diameter D. And FG will be equal to, if I divide it by 2, so it will be equal to FG. And this FG is again equal to AB. Clear? So AB will be equal to D minus D divided by 2. So I will put the value of AB over here. Clear? So tangent of alpha is equal to D minus D divided by 2 into L. And again alpha is equal to tangent inverse D minus D divided by 2L. So this is formula for finding out tapered angle for producing the tapered part. I think it's very easy. So again I will repeat, tangent of alpha is equal to AB over BC. AB is this perpendicular distance and BC is this base. So you can see from here, if you do not follow these things, so you can see easily that this distance is equal to, if you, this is D and this is small d. Clear? This is small d. If you subtract d from, if you subtract this small d from this capital D and divide by 2, so you will get this distance or this distance. Both are same. So d minus d divided by 2 will give you AB. So AB is equal to d minus d divided by 2 and BC is the length, which is L. And alpha is equal to tangent inverse d minus d divided by 2L. And this is formula for finding out half tapered angle for producing tapered parts. So this is the same formula. Now we will look into some small problems. So but before going to that, I will explain another term that is known as conicity. So conicity. And this conicity is represented as K. Now this K is equal to d minus d divided by L. So how we can define conicity? Conicity can be defined as the ratio of difference in diameter to its tapered length. Again, the ratio of difference in diameter to its tapered length. This is known as conicity. Conicity has no unit and it has a simple value. For example, if D is equal to 90, capital diameter is equal to 90 millimeter and small diameter is equal to 80 millimeter and tapered length is equal to 100 millimeter. So you can find K. So you have to just put value 90 minus 80 divided by 100 here, which is equal to 10 divided by 100 or equal to 1 over 10. So K is equal to 1 over 10. The upper value is actually D minus D and divided by L. Clear? So D minus D, let me write D minus D divided by L. So you can see change in diameter is 1 over 10, which is the tapered length. So means 1 millimeter decrease in diameter when you move a tapered distance of 10. So let me show over here. For example, this capital D is equal to 90. Clear? This small d is equal to 80 and this tapered length is equal to 100. So when you move from this or to this. So if you move at a distance of 10 mm, let's say this distance is 10 mm. So here the decrease in decrease in diameter, difference in decrease in diameter will be 1. Similarly, again when you move 10 millimeters, so again difference in diameter will be 1. So if you move 10 times, so diameter will be equal to this one or this one. So again conicity can be defined as the ratio of difference in diameter to its tapered length. It's a number and it shows you that the difference in diameter per unit length, or you can say per unit tapered length, or per tapered length is this much. So here 1 millimeter diameter is decreasing when you move 10 millimeter in its tapered length. Okay, so we have this formula, K is equal to D minus D divided by L. Again, if you multiply L on both sides, so we have KL is equal to D minus D. Clear? So now you can see this formula or this formula. It has 4 values: K, conicity, larger diameter, smaller diameter, and tapered length. So if you know any three of these values, so you can calculate fourth one. For example, if you need K, so you must have D, small d, and L, so you can find this tapered length. So if you need tapered length, so for that you need D minus D over K. So L tapered length can be calculated. Again, if you need capital D, so capital D will be equal to KL plus small d. Clear? Similarly, if you need small d, so this small d will be equal to capital D minus K into L. So you can have different values. Again, if you remember this, so you can find out any one value. Clear? Again, there are certain small problems that can be given in order to find the required value, either K or small d or capital D or tapered length. Now I will move further, as we know that tangent of alpha is equal to D minus D divided by 2L, and again you know that this I can write it as D minus D divided by L into 1 over 2. Clear? And this D minus D divided by L is actually K, which is conicity, multiplied by 2. So tangent of alpha is also equal to K over 2. Again, if you know conicity, you can find the half tapered angle. Clear? So in this, the above example where K is equal to 1 over 10, so if you put it, so implies that tangent of alpha is equal to 1 over 10 into 2, which is equal to 1 over 20. So alpha is equal to tangent inverse 1 over 20. Tangent inverse 1 over 20. And if you calculate this angle through calculator, clear? So let me calculate it. This tangent inverse 1 over 20 is 1 over 20 is equal to 0.05. Clear? And you take tangent inverse 0.05. So this values alpha comes out to be 2.86 degrees, 2 degrees, and so this is the value of angle alpha. So this half tapered angle we have calculated over here will be set on lathe machine for compound rest method. So you have to rotate the compound rest at an angle of 2.86 degree, and in this way you can perform the taper turning operation. I hope you have got the concept of how this formula tangent of alpha is equal to d minus d divided by 2l comes on. Thank you for watching the video.